Hello students, I welcome you in the lecture series of electronic devices circuit. So, in this particular lecture, let me choose pen first. Okay, yeah, just a minute. Yeah. So, in this particular lecture, we will discuss about the DC biasing of BJT. So, what exactly mean by DC biasing and BJT? We know that. So, BJT is nothing but what? BJT, as far as BJT is nothing but what? This is the bipolar junction transistor. Bipolar is bi means two. Okay, polarity. So bipolar is nothing but the two polarity, that is the holes, that is the positively charged, we can say that, and electrons are negatively charged. Okay, so as I am talking holes as positively charged, but it is not exactly that one. So holes are nothing but the less mobile electron which required a positive charge, that so that will move. We have discussed this part in the previous lectures. If you are not seen, so please go through this. Okay, so BJT is divided into, just a minute, where is my pen? Yeah, into NPN and PNP. Okay, so we will see this part in this particular lecture. So before starting, so if you are not subscribed to my channel, please go through the subscription. If you are subscribing in the channel, then you are getting the latest updates of each and every video which I have uploaded on my YouTube channel. So go through it and you can browse through the playlist and you can watch the entire video series of electronic devices and circuit. Each and every lecture is recorded over there and you can watch the entire video series of electronic devices and circuit. So what exactly mean by biasing? So biasing is nothing but what? Biasing, this term is nothing but to apply an external DC supply to the transistor in order to turn it on. Okay, so what exactly mean by biasing? So this module is the heart of your subject or the analog electronics. Whatever this, just a minute, I will enter this part. So as far as this amplification process is concerned, so what exactly mean by amplification? So now I will give you one example. Let's suppose this is your head, okay, head I am saying, and if some problem is there in the head, so what we are doing? We are connecting one. This is my computer, okay, computer, and here you will getting graphic of what? EEG, that is electroencephalogram. Okay, this will give you the activities of heart. EEG graph, it is saying that. So this is my computer, okay, PC, I will say that, personal computer. So this is my head, this ear over here. Okay, I will draw something for you. So this graph is plotted on this computer, but for that what I have to do? I have to connect some electrodes to my head, electrode to the patient's head. Instead of my head, I will say patient's head. So that electrode are taken into bunch, that wires are taken. Okay, these are the wires we have taken to a circuit. So this, whatever this convert my physical activity into electrical, so I will say that it is a transistor. Transistor. After that, these signals are very small, that is nothing but the micro volt itself. So the PC required a 5 volt signals in order to plot. So in between that, I have to connect one circuit that is called as amplifier. So my 5 millivolt signal will convert it into what? 5 volt. This is an example I am saying. So less millivolt signal is converted into more volt signal. For example, 5 microvolt is converted into 5 volt itself. Likewise, if I want to change the amplitude or amplification of the signal, I want to go for the what? I have to go for the amplifier. And to turn on the transistor, I have to give an external power supply, that is of DC signal. So to give the external supply to turn on the transistor turn on the transistor, so that is nothing but the biasing. That is nothing but what? Biasing. Okay. So I think you are getting the concept, what I am trying to say. Just a minute, I will rub this portion first again. Yeah. So this is all of this. Again, example of amplifier. What exactly mean by amplification? Suppose this is the auditorium. Okay, this is the auditorium in which I am standing over here. This is a stage over there, and I am standing over here. And the last sitting person. Suppose this is the capacity of this is nothing but the 300 or 300 people. 300 people can stand. But if I am talking without mic, without microphone, then what will happen? Last sitting person cannot hear me. Last sitting person cannot hear me, and I have to loud myself, my voice, and I will get tired within 5 to 10 minutes. So this will case will happen normally. So what I will do, suppose I will take a mic device called as mic. Mic is nothing but what? Microphone. So this is my low intensity signal. Here my voice is. After that, I will connect this signal to one device that is called as what? Amplifier. I will connect to amplifier, and this amplifier is connected to what? Loudspeaker. Connected to what? Loudspeaker over there. So with the help of mic and amplifier, I will loudspeaker, my signal, that is the low intensity signal is converted into large intensity signal over there. Okay. So this is happen with the help of what? Amplifier. So the amplifier is used for this purpose only. Okay. So I will choose pen. Yeah. So what exactly means? This is the graph you have seen. If you have not watched these videos of previously which I have recorded, uploaded on my YouTube channel, so please go through it and watch it carefully, so you will get the graph of it. So what exactly mean by this operating point over there, for example? So I will show you one amplifier circuit. This is my amplifier circuit. Here I will connect a mic, and here I will connect a loudspeaker, small loudspeaker. So I will get an amplifier circuit over there. So how to design this amplifier, that we have to see in this particular lecture. Means what? Here you will find one RB over there. Okay. Here you will find a RC over there. Two components I have only connected, and how much power supply I have to give over here? How much power supply I have to give when if my signal is something, and what kind of amount of signal I am getting at the output, that we have to see. Okay, that we have to see. So this is nothing but biasing. So what you have to do? How much current is caused to flow? That IC we have to find out. This IP we have to find out. This VC we have to find out. It's all things you have to find out, because they will give you ready-made this RB, ready-made this RC, ready-made this VC, and you have to find out what is the current of caused to flow, and what current of caused to flow, that is nothing but the IC and IP over there. So this kind of things you have to do in this particular lecture, not lecture, module itself. So this operating point I will discuss afterwards. I will skip this point for a while, and I will discuss afterwards. So as far as this operation is concerned, there are three regions: active region or linear region we are seeing, cutoff region and saturation region. I think this part I have covered in the previous lectures at the time of BJT. I have connected to the BJT. So this portion which I have drawn over here, this portion is called as cutoff region. Cutoff means what? In this region your transistor will act as a open switch, which means what? Suppose this is the switch and this circuit is like this one. So open is now what? If your circuit is open, then no amount of current is flow, and this is closed switch. This is the closed switch. So closed switch is nothing but what the current is caused to flow in between this if you are pressing this button. So that is nothing but this is the saturation region over here, the maximum current caused to flow over there, and remaining region, this portion is nothing but my linear region. Here your amplifier will act as your transistor will act as an amplifier. Means what? Just a minute, I will rub this portion. Means what? Suppose for example I have chosen some value of RC and RB over here. Then I will get some value of IC and I will get some value of VC. Suppose after choosing this thing, if I am increasing the value of VC increasing, so my IC is also increasing, IC is also increasing. So second graph I will choose because it is value having something. So if this value is given to you, so if I am increasing the VC, my IC is increasing. After some time, my IC is saturated. That means it won't get increase. After this point, it won't increase. It will get flat. It will get flat. Whenever you are using your VC, increasing your VC, IC is very small. Very small. Not. It is stable. Likewise, for second, VC is increasing. After that, it will get stable. So whatever this point at what your IC is getting maximum value, that is nothing but my saturation. So these are the different value of my different value of IB over here. Means by setting the value of IB, I can obtain the different value of VC and different value of IC over there from this graph. So if my transistor is in the active region, so base to emitter junction, keep in mind always it is in the forward bias. Forward bias means what? Suppose this is my PN junction. P and N junction, and I am having battery that is positive and negative two terminals are there. If P connected to the positive terminal and N connected to the negative terminal, so this is nothing but my forward bias. And what about reverse bias? P connected to the negative terminal and N connected to the positive terminal. This is nothing but my reverse bias connection. So keep in mind, base to emitter junction is always forward bias and base to collector junction is always reverse bias in the active region only. And in the cutoff region, both are in the reverse bias. Keep in mind, both are in the reverse bias, and in the saturation region, both are in the forward bias. So here, in this particular region over here your transistor will act as a amplifier. So in this one, your base to emitter junction is forward bias, and your base to collector junction is reverse bias. Here, if your current is maximum here in this region. Your current is maximum, that is nothing but saturation. Both the junctions are in the forward bias because it will conduct more current. And if I am thinking about this portion, this bottom portion, this is bottom portion. I am saying this is bottom portion. So here both junctions are reversed by, that is no amount of current caused to flow. Okay. So what are the techniques of DC biasing? This we will see, and I will stop over here. So there are 5 techniques of biasing: fixed bias, emitter to emitter bias technique, or emitter stabilized technique, collector emitter loop voltage divider, and DC biasing with voltage feedback. These are the 5 techniques, important 5 techniques, but you will find a definitely question on this voltage divider bias. 100% we will find a question on this one. And keep in mind, this module is near about 525 marks. 25 marks. This module, if you are comfortable with this, EDC is very easy for you guys. Very useful for you guys. Okay. So after this note, I will stop over here. Thank you very much for attending this lecture. Thank you.